Hi, everyone, and welcome back to the AI Interconnect Podcast. I'm your host, Lauren. Here we spotlight founders, operators, and decision makers building smart AI power system across PropTech, FinTech, SaaS, and beyond. Today, I'm joined by Rajiv Chandrasekaran, co-founder and CEO of Quantum Data Technology. And Rajiv's team is behind some of the most forward-looking tools in predictive analytics, enterprise forecasting, and no-code ML. Rajiv, thanks for being here. Welcome to the show.
Thank you for the introduction, Laurent. Happy to be here and looking forward to the discussion.
Wonderful. Me too. We don't have to do it too techy, huh? Not techy.
Okay. Yes. Keep it simple.
Keep it simple. Let's start at the beginning. From those who don't know your background, obviously, can you share a little bit your personal journey before QDT?
Absolutely. Yes. So my background is in engineering. I'm an electrical engineer by training. So I got my PhD in wireless communications. My first venture was a startup in California. It was a VC funded startup called Fujant. We were investing in 3G technology at the time, and my role was building some of the algorithms for their 3G wireless systems. So I got my training and I spent a good 15 years in telecom building advanced systems for networks, wireless networks, LTE systems. The R&D team globally for our company was acquired by a spinoff from Lucent Bell Labs. At that time, I moved to New Jersey from California, and I spent a good many years developing technology for 3G and 4G wireless systems, which was really the foundation of a lot of the work I've subsequently done at QDT as well. So building real-time algorithms for, at that time, 3G and 4G systems, and some of that has translated into some of the work I do right now.
That's great. I love it already. Very, very curious of all this. Then, what gap did you see in the market that made you say, we need to build this?
Yes, part of it was a personal story because I was always, from my background in telecom, I was always building real-time algorithms. So my interest was in seeing how we can use mathematical techniques to do quantitative trading. So essentially it was how can we use forecasting techniques to do quantitative trading in the markets. So that was the genesis of it. So I started looking at technologies and techniques to do that. Quickly realized that in order to do this effectively and at scale, you need a lot of fundamental building elements. We need a significant data platform. We need to improve upon our forecasting algorithms. So that is the genesis. And I met my co-founder who had similar interests in financial fintech. He came from fintech as well. So we decided to form the company initially, honestly, to invest our own capital and money using mathematical techniques. And then in the process, we built a really powerful platform using machine learning and AI, which we've then applied to various use cases. Right? So that is the journey. And then, yeah, it's been an exciting journey so far. And you can tell from the name of the company as well that we've gone through many changes, and I'm happy to talk through what our initial objective was, what our initial thinking was, and how it has evolved as we've grown from the initial phases.
Yeah, I mean, definitely. Then you're started on the market doing quantitative models for the market. That's what you did at the beginning.
Yes, that's what we did at the beginning. Yes. So we built quantitative methods. So when we first started the company, high frequency trading was a big component of financial markets. So, and my expertise was in some of the technology that goes into high frequency trading, which is I had applied in telecom before, using field programmable gate arrays and technology that's now evolved significantly since then. So we built some of the early algorithms on those accelerated hardware platforms to accelerate trading. But then we realized that part of the trading markets was quickly coming to an arbitrage where almost everyone, there was no additional alpha to be made in those techniques. So we evolved and built newer algorithms to kind of improve upon our trading strategies and quantitative trading.
Okay. Yeah, I deviated a little bit because I have a passion for the market, and that's why I asked you this question. But let's come back to
Yes.
the real thing. So let's talk about quantum data technology. What problem are you solving, and for whom?
Okay. So When we first started quantum data technologies, as you can tell by the name, we were looking at quantum computing as a means for building solving optimization problems in supply chain, finance, marketing, any kind of application we can think of. So we partnered with D-Wave Technologies, IBM and built some of the early versions of our algorithms on those platforms to address those potential problems. Right. After an initial phase, we quickly realized that quantum technology was great. Some of the potential was amazing, but it was a long ways away from being commercially viable. So we quickly pivoted to applying what at that time what we currently call AI or classic AI and machine learning techniques to solve problems. And then we started with financial markets, but then we've since applied the same platform to solve problems in marketing analytics, supply chain analytics, risk forecasting for commodity analytics, among others, right? And we also have tested use cases in healthcare as well. But our biggest success has been in the financial markets, marketing analytics, and risk analytics.
Okay. Okay. Then I come back to this. With the financial market was still under the same name, the same company, Quantum Data Technology.
Yes, it is under the same name, Quantum Data Technologies. Our thinking also was that quantum techniques can get us better optimization solutions for financial markets, better portfolio optimization methods, better risk estimation methods. And the promise is still there. If quantum technologies, once they become the number of available bits, qubits increase, some of the classical problems in quantum in financial markets will become easier and easier and increasingly more effective to solve with quantum computing, right? We continuously evaluate quantum computing even now, looking to see where we can get an advantage over the competition by looking at some quantum algorithms. So our genesis is still forecasting for financial markets, which we've then applied to other use cases.
Okay, then I don't want to go into too technical, but what is quantum machine learning and who use it today, or who are your clients?
Yeah, so the who our clients are, when we first started off, our clients were small and medium sized hedge funds who were using our machine learning algorithms to generate some alpha. Then currently our biggest customers are large enterprises, so commodity trading desks and large enterprises. They use our platform to forecast commodity prices for procurement. For example, if you're large enterprises, that's CPG companies that manufacture goods at scale, they need to procure commodities like sugar, wheat, rice, cocoa, crude oil, energy commodities. And these are all procured on the open market. And the biggest challenge they face is that these commodity prices are driven by traders in the market, namely the hedge funds and other trading desks. But meanwhile, the enterprises have the challenge of procuring these commodities at the lowest cost and lowest price. So they use our machine learning platform to help them procure these commodities at the best available prices and best available financial markets, and help them plan for production, and also helps them hedge risk. If they anticipate using our models, if there's going to be significant movement in commodity prices, they can hedge their risk, financial risk. So it helps them manage their finances as well. So those are our primary use cases. And I've said we've grown since then to apply that to quantum machine learning to other use cases. Where marketing analytics, specifically allocating marketing spend and promo spend across enterprises to maximize sales. So that's been a secondary application. And the third big application for us has been we provide these services to the Office of Naval Intelligence. So we have a contract with the Navy where they use our platform to predict commodity trading risk. The Navy wishes to know United States government assesses risk to commodity trade flows globally. So if we monitor trade flows globally, and they use our software to monitor the risk of commodity flows due to global macro events, external weather events, macro factors, financial risks, and so on.
Wow, I start to understand, and I love it. I love it. How does your approach differ from traditional data vendors or internet data science teams?
Yeah, so one of the things we realized was when we built the platform is there are three dimensions that move any machine learning or AI platform. The first dimension is data, right? So we quickly realized that in order to do some of these techniques and estimation techniques, you may have the best algorithms and the best techniques, but if you don't have the right data sources, then a lot of those algorithms fail. So we put in a significant effort to procure and build our own data platform from globally sourced data sources, both paid and unpaid data sources, which we've organized. So we collect data from financial markets like Bloomberg, Thomson Reuters, NASDAQ, NYSE, global exchanges. We get weather data from specialized weather sources. We get logistics data from shipping companies. We procure GPS data. So we have a giant data set of really curated data sets which are ready for machine learning. So a significant portion of our IP is in organizing these data sets and also curating them to be able to be ready for machine learning. So we have several 100,000 data sources that we currently globally monitor every day, and then we procure them and then maintain them in our database and make it available for machine learning. So that is one significant advantage we have over a lot of the competition, where they may have the best data science teams, but if they don't have the right data, it's difficult to do these data science, solve these problems. The second, of course, is the data science itself. We have innovated significantly, where our expertise is in, we use the best in class open source algorithms, but then we apply our own IP on top of it to make it computationally efficient, as well as being able to, we've applied we have some custom IP as well, on which we applied on top to make them more effective for forecasting applications. And one of the guiding principles for our methodologies is similar to the way we've tried to replicate how human beings think and act when they make decisions, complex decisions, right? So if you imagine a boardroom where a CFO or a CEO is trying to make a complex decision on whether there's investments or procurement, he has several experts at his hand. He may have his CFO giving him an opinion. He may have his macro expert giving him an opinion. He has market analysts giving him an opinion. And he takes all those opinions and then makes a complex decision on whether to invest in some venture or acquisition. So we apply the same principles to our machine learning. So machine learning replicates, we build several, I would call, machine learning expert models to replicate each of these functions. So when you're trying to procure commodities, we build a macro expert, we build a technical analysis expert, we build a weather expert, we build a hedging expert. And each of those expert models provides an opinion on what decision to make. Our key IPs and how we collect all those expert opinions and then translate that into one or few decisions that the decision maker can then make, right? So you try to replicate human thinking, what I would call, we call that super forecasting, based on the techniques that are available, that have been publicized. But that's a basic methodology. Is our science is building complex expert models and combining those expert models into one complex decision.
I think I had a question, but that was exactly the answer. Your platform help decision makers move faster and with more precision, basically.
Yes, it helps them move faster with more precision. And then it does, and our firm belief is any of these complex decisions, you cannot take the human out of the loop. So we've automated what we think a human expert does in these expert models, but the decision as to how to weigh those expert opinions and then make the final decision, the machine can give an opinion, but the final decision a lot of times is made by a human being. Should I buy this? Should I buy crude oil today? How much should I buy? The machine will give you an opinion, right? What it thinks is the best based on all of expert opinions. So we've built our tool to be quite integrated with human decision making, which is why a lot of the enterprises like our software, because it doesn't take them out of the loop. At the same time, it gives them a pretty complex set of metrics on which they can make a decision.
I love it. Okay, let's zoom out. Across AI, privacy, compliance, and big data, what shift are you watching closely?
Well, of course, the biggest shift we're watching is the way enterprise AI applications are being built and transitioning because of the revolution that's happening with large language models and Gen AI, right? I think what used to be traditionally in an enterprise, decisions were made there were multiple pieces of enterprise software, could be ERP software, could be procurement software, and all of those independent pieces of software that were then tied together by code written by human beings were purpose built for those applications. Now, what that's changing is because these AI systems like LLMs are able to comprehend and grasp complex, large amounts of data without having to write purpose-built software. It's migrating towards AI agents, which are inferring what these data means and then the codifying of these decisions using AI agents. We see that as a big change. It has challenges because a lot of times unless the source data is curated well, some of the AI agents, there's some transparent, some of there's lack of transparency sometimes on how the data is being processed. So that's one of the biggest challenges we're seeing. We recognize that enterprises have to move in this direction because this is much more efficient, much more agile. It can help them create new potential applications much faster. But at the same time, it has challenges because unless the data is prepared and curated in the right way, these AI agents can mislead you sometimes unless it's carefully thought through the whole process. Whether it's compliance or the compliance has to be transparent, making sure the information is accurate. So there is a lot of those challenges are being addressed, and that's where we're also playing a big role in some of the development we are doing in enterprises right now, is helping them manage those challenges.
Yeah, and right. And what's changing in a way enterprise buyers approach forecasting and analytics?
I would say the traditional model if you look at large enterprises, they have, many of them have siloed analytics teams. So they have there are duplication of functionality is very common in large enterprises. So there may be marketing analytics teams for product A, there's a marketing analytics team for product B, and so on. And a lot of these analytics teams were consultatively built. Yes, there are off-the-shelf solutions for a lot of these problems. A lot of these problems were built consultatively using some consulting help, right? So they were purpose-built by combination of internal teams and then external teams building a product built to some specification. So we see that changing quite a bit, where enterprises recognize that with AI, there's a significant opportunity to consolidate some of these teams into a centralized function and then use a centralized knowledge and a context-based AI to help them make these teams more efficient, make these teams more productive, and also make these teams more accurate in their decision-making process. So one of the big changes we're seeing is enterprises are rethinking the way these teams are structured, where perhaps you don't need a team, 5 different teams doing similar activities. If you can use a combination of AI-based, knowledge-based decision making and centralize the way these applications are built, you can probably do it with a much more smaller team, which is more productive, more efficient. So that's one of the big shifts we are seeing, and I think we'll continue to see that in the next few years, as enterprises try to be more efficient in the way they do these analytics.
Yeah, yeah, for sure. And is adoption being driven by more by cost pressure, complexity, or regulation right now?
I would say it's all of those. So the adoption is being driven by a combination. Cost pressures definitely is one of the big drivers in any enterprise. Of course, promise of AI is it helps you be more productive. Productivity can help you be more efficient in your cost structure and be more accurate in your decision making. So cost pressures, whether it's in the way teams are structured or where these software is built, perhaps you don't need a team of 10 data engineers and 10 data scientists and 10 UI engineers to build a product. You can probably build a team with a much smaller team. And also, if the same team can build you many more use cases, right? So there's an increasing awareness that teams, and we've seen that in our own team. We started with a small team, but the same team has been productivity has significantly increased with these use of these AI tools for coding and software development. And regulation too. Regulation is, I don't know if it's a big driver, but it poses more of a challenge, I would say, because AI sometimes obfuscates what's really happening. So regulation is, you may need more resources to address the regulation problem so that might actually require more resources than before because of the way regulation works, basically. So.
Yeah, yeah, maybe. Yeah, that makes sense. Are you saying certain industry move faster, like supply chain or maybe defense or financial services?
Yeah, we've seen all of these. I would say all of these in the defense sector. I mean, a great example is the industry leader Palantir. Palantir has been pioneering AI in defense analysis for a while, and we've been our software is a small part of that. So the intelligence software we built for the Office of Naval Intelligence is a great example of how a small efficient team can build a complex piece of software to do pretty amazing things in terms of monitoring global trade risks and analysis, right? So, in defense industries, we see a big opportunity. Financial sector is that's where we got our foothold. They're always the nice thing about financial sectors is it's easy to see the actual ROI in actual dollars, because if your trading system works, then you make some money. If your trading system doesn't work, it doesn't make you money. So it's much easier to see the return on investment. So, and supply chain as well, because some of these more complex supply chain problems require real time optimization, real time logistics. So the new systems have seen a significant improvement. So I would say it's a universal change. Everything that could potentially be optimized using more complex systems. Everywhere enterprises are looking to optimize these systems in every way they can. Our biggest traction has been in financial services and supply chain and the defense as well. But we see this, but I think in the defense sector, even though they're more cautious, but you can see the rapid adoption of some of these new AI tools, right? So even in defense analytics.
That's amazing. And let's move on. Every funders run into walls at some point, or maybe.
Yes.
What are some of the biggest challenges you face building QDT?
I would say the biggest challenge is anticipating what the technology change is going to be. And you can try and predict what the technology is going to move. I can give you examples. When we first started, we thought quantum computing was going to be the big thing. We spent quite a bit of time. We quickly realized that was not commercially viable. Then we migrated to using real time hardware, using what at that time was the best technology, because it was being used in crypto mining, real time FPGA systems. But then NVIDIA came along and then came up with the GPU architecture and completely changed the paradigm of what could be done with compute hardware. So there's innovation in compute hardware, which completely can change your perspective, and you have to change directions. And if you set along a path, you may have to quickly understand that that's not the right way, and then it may be lost opportunity cost. But it's better to pivot and then anticipate the technology. So we've run into issues where we've invested significant amount of capital and time building solutions using these, but then we had to abandon them and then switch to the new technology. And I don't know what's going to be next. Like earlier this year, we saw AI systems. We thought the cost points were X, but then DeepSeek came along and the cost points changed significantly. That changed the way we could do much simple some of our systems as well. So, and there's constant innovation in the way algorithms are evolving. So, and because of the open source community, there's a rapid adoption of new techniques, right? So I think that's helping us. And the innovation in AI, the competition between the LLM players in the market, whether that's ChatGPT, Claude, and Gemini, and all of the open source models, the innovation is moving at such a fast pace that you have to keep track. So that our biggest challenge in the past has been we've picked a path, we think it's viable, but it may very likely change in 6 months, 9 months. Sometimes we may spend a year or two doing something, and then you quickly have to pivot. But that's where we've been uh, we've been effective in kind of quickly changing directions and recognizing that there's a paradigm shift in the way things are happening in the market.
Yeah, you have to be quick.
Yeah.
And how hard is it to sell a product that blends AI, quantum concept, and enterprise forecasting?
It is hard. It's a consultative sale. So there's a the re rec the from one point of view, our customers realize that AI and the use of these techniques will help them be more efficient. But there's also fear that it's going to take away their jobs. So the biggest challenge we face in the sales process is, are we taking away an analyst's position? Because what would be traditionally considered an analyst in a big enterprise, their job could potentially be impacted by some of the techniques, the new software, the solutions we build, right? But I think that's where we have. So it's a challenge, and it's a reality as well. Some of the traditional jobs are being replaced by what I would call intelligent machines, but it also helps them be more efficient. So what's helped us, let me give you an example. A commodity procurement desk at a big enterprise may have 10 procurement analysts, right? And some of them are very good because they have an expert knowledge of the market. Some of them may be below par because they don't have as great an understanding of the market. And they start using our software. And what you find is the best commodity procurement analysts, maybe they see a very small improvement in their performance, or maybe they're already at the top of their performance. It doesn't significantly improve. But the analysts which are previously were less productive, using our software now become much more productive. So the average performance of the team rises, right? So they recognize and that is one of the things that led us to the success, is that it levels a playing field where people who use the technology effectively can be much more efficient, can be much more productive, can be much more. So it doesn't take them out of the loop, because the decision to, like I said, that's why we made it a very conscious decision to recognize that the human in the loop is a key thing, especially when it comes to making enterprise decisions, because every decision has some uncertainty and unknown factors, which you cannot account for everything that you know based on everything you know. So there's some instinct, and or you may call it instinct or expertise or just knowledge, subject matter expertise, which helps them make the decision. And that is a key element, right? So you can automate a lot of the things, but when it comes to enterprises, you have to have the decision makers in the loop. And
Yeah.
it's a complex sales process, but there's also recognition from our customers that they need to move quickly in this direction, because if they don't, their competition is likely to move and they don't want to be left behind. So there is also an incentive which helps us pitch our solutions and helps us move them in the right direction as well.
Yeah. I mean, that was a great example. Buyers, your clients, clear, or future prospects are clear on the difference between what you do and the typical dashboards, BI dashboards.
To a large extent, yes, because when we sell, we make it clear that BI dashboards are just a way of accessing what's already there. We don't build BI dashboards; we build purpose-built products and solutions. So I think that makes it the challenge as well, because sometimes a BI dashboard may be perceived as being the actual analytic solution, when in fact it's what's behind it may be pretty rudimentary or not very effective. So when we sell a solution, it's purpose built for a specific use case. So whether it's a commodity trading desk or a marketing managed CMO team that's trying to optimize its marketing expense, or a supply chain analyst who's trying to minimize waste or improve logistics performance, right? So we build purpose-built solutions. And when we build the solutions, we build the entire stack. We source the data, we have the algorithms and the UI that goes with it. So we don't do standalone dashboards. We don't do standalone pieces of code that they use, basically.
My mistake. And what has been the most misunderstood part of your platform or value proposition?
I think there's misunderstood. The biggest thing in financial markets, the biggest thing the biggest challenge for us has been to try to convince customers that there is still a lot of randomness and unpredictability in everything we do, right? So we can build the best models, but there's an expectation that if you use complex AI and machine learning, you're going to be right all the time. The biggest challenge and the misunderstanding is that, we'll throw more compute power, we'll build better models, we'll build more complex models. It's going to get more and more accurate. But everything has a fundamental, whether it's commodity prices or customer purchase behavior, there's sufficient randomness in that behavior that you cannot just model out. So a lot of times the biggest challenge we face is, we used your model, but you said our marketing effectiveness is going to go up, but this quarter my sales has fallen. And then we have to, and the reason it does it is because there's inherent uncertainty in the way customers behave, even if everything else is right. So you're correct in the long term, but you're maybe wrong in the short term. So it's like financial markets, right? So you make money in the long term, but the day-to-day fluctuations are largely noise. This idea of statistical arbitrage and this bias towards short-term and near-term memory is the biggest challenge we face. Is not every decision you make is going to be right, but on an average, you're going to make more correct decisions using AI, right? But you may have, it's easy to see in financial markets because it's a random walk, but it's true of every complex decision you make, because the way consumers purchase in the market, the way supply chain logistics move, the way weather events happen. There's enough randomness. You cannot predict everything, but you can predict things on average over long periods of time. So convincing them of that principle is the biggest challenge for us. It's the really good enterprise teams recognize that, and then they invest in it for the long term. So, we've seen instances where there are short-sighted teams which may look at short-term performance and then think that the AI is not their answer or this solution is not the answer, right? So that's the challenge we face, is convincing them that we can put in our best efforts. We can have the most predictive model in the world, but it's not going to be able to predict everything because there's enough randomness in the way the world works, basically.
Yeah, that's true. On the financial market, people are maybe, what can I say, impatient about results, even though long-term expectation or return uh, are better on a statistic level. But everybody should understand the game of the numbers,
Yes.
basically.
It's a game of statistical arbitrage, and it's true, very true in
Exactly.
financial markets. It's true of everything, any kind of complex system that you model, right? So it's uh, on any given day you could be wrong, but the game is to be right in the long term, right? Or more right than wrong, right? So,
Definitely, definitely. Let's fast forward. Where do you see QDT in the next 12 to 24 months?
yeah, so we're seeing a rapid adoption of these AI agent-based systems, right? So the classic approach of building applications using a stacked layer and then custom build UIs, we see that quickly migrating towards a platform where people are used to now going to a Gen AI agent and asking a complex question and expecting an answer, right? So if you want, right? So, and we do that in our daily lives, in our personal lives, and that's going to be the expectation in enterprises. They don't want to open up an SAP system and then open up a chart and open up an Excel spreadsheet and get an answer. They will want an agent where they can ask a query and get not just a textual answer, but also get complex responses, the analysis behind it, the charts behind it. So that's going to be the expectation. So we are migrating towards that vision where we recognize that this is the way people are going to interact now through these interfaces, which are more human like. So any enterprise application with the commodity trading desk is no longer going to open up a Power BI dashboard and then look at a chart and then make a decision. They're going to ask, what should I do? Perhaps have a conversation, and then analyze the conversation and produce a report, perhaps, and then make a decision. So it's a combination of AI agents, it's a combination of implementing some new architectures. So we see that as being the biggest opportunity as well as the biggest push for us in the next 12 to 24 months. And we're rapidly moving towards integrating all our solutions into this kind of centralized approach where you come to QDT. Hey QDT, tell me what I should do for pricing. Should I increase the price of my goods next quarter because of global factors? And the software behind it should automatically use the analytical tools with the forecasting tools, and then produce a report and a decision that you can then, if you're a CFO or procurement manager, you can make a decision on what to do. So that I think is be the biggest change. And then these expert systems will evolve, where right now these expert systems, the other big change I see in the next 12 to 24 months is we used to these expert AI systems like LLMs sitting in a centralized cloud where we access them through a token or an API, right? But I think with NVIDIA coming out with new hardware, which could be personalized AI assistants, you can have your own personalized version of an LLM sitting on your phone or your desktop, which mirrors your personality and decision making. So these personalized AI systems, we can have your own Laurent's version of an LLM, my version of an LLM, which will talk and think like me, and then replicate the way I do thinking. This will make my life more efficient. So I see a lot of that happening at enterprises as well as at a personal level.
Very nice. And what does success look like for you right now in 2025?
Success looks for us if we can make this transition, which I think is a transition happening right now in all enterprise systems as well as systems, is the way context-based AI systems are rapidly evolving to be the way people access information. If we make the transition to take all our solutions, which are all currently all our solutions are SaaS solutions, classic SaaS solutions, we're migrating towards Gen AI. We have Gen AI overlays. But I think if we make success to me looks like if we take our whole platform and migrate this to this vision I was saying, which is personalized QDT expert that he can ask any complex question about, and then he can have it do complex tasks at an enterprise. And if we realize the vision for some of those use cases we've talked about, that to me is will be success, because that will be gain immediate traction in large enterprises, as well as I believe that's the way. So say these knowledge systems are going to be built in the future for us.
Okay. And are you looking for new verticals or international growth or deeper future products, features?
Yeah, the features, I said, I just talked about how we are more reoriented the architecture. In terms of growth, we are looking to grow internationally because there's rapid adoption of these AI and machine learning systems globally now. Until now, our primary market has been the United States, and we have had some, but we have had a partnership with the National Stock Exchange in India, for example, and we had some success in India. But we are seeing a lot of investments happening in the Middle East, Europe, in these AI systems as well. So we hope to grow internationally through our partnerships, as well as some of the enterprises that we build solutions for. They are global enterprises, so they deploy our solutions in globally. So international growth is the biggest opportunity for us. So in terms of verticals, we anticipate we'll still focus on these 3 or 4 primary verticals, because we believe there's enough growth in each of these verticals that we can still tap into: financial services, supply chain, marketing analytics, and then this defense related AI. So those are the 4 broad verticals. And we also have some strategic partnerships we are hoping we will, especially on the financial sector side, with the Chicago Mercantile Exchange, that we anticipate will grow as well, because a lot of the exchanges are also changing their and adapting their solutions to address this AI market, and we hope to be part of that growth as well with them.
And do you believe AI native forecasting tools will become the new standard across sectors?
Yes, absolutely. Yes, I believe so. Yes, because in 2 ways, if you think about what LLMs do right now, they are essentially text-based forecasting tools, and they have become the norm for text-based data pretty much as a standard. We use them as knowledge sources, but they're forecasting tools. Right? They predict the next text essentially from a knowledge base. Now, people are applying that same methodology to numerical data, and there's a lot of innovation happening in that space. Google has released a foundational model in numerical forecasting, and we have our own forecasting methods, and we are using those AI based forecasting methods and enhancing those using our own methodologies. So doing complex forecasting tasks, AI will be using these new AI based, when I say AI, it's these classic transformer based techniques that the GPTs of the world have come up with. Those will become the norm in the next few years. And numerical data provides more challenges because it does not have a structure like language, but there are ways to address those challenges, and those are being done using foundational models. So I believe just like we have foundational models for LLMs, language models, we'll have foundational models for other numerical systems as well. Once you have the numerical information and you have the textual information, then that gives you a comprehensive AI solution for essentially forecasting anything at scale, right? Using the best method anyway.
What's a common misconception about real-time analytics and predictive AI?
I think the biggest misconception is that better and better algorithms can give you increasing accuracy. It goes back to the uncertainty, as I said. The biggest misconception I see is that a substantial portion of what nature works like is random, right? So it's financial markets is easy to see, but the randomness is the biggest misconception that real time can solve that, and fast computational can solve that, increasing compute can solve that. Yes, it can make it more and more accurate, but there are fundamental limitations to the way knowledge is created. So I think that's the biggest challenge for whether it's real time systems will get faster. Decisions that take seconds now might take milliseconds, right? That will happen. Fundamentally, those quality of those decisions will not improve at the same scale as the speed of those decisions, right? So that's
That's right. I agree. What will you tell early stage funders building a B2B tool in technical space?
I would tell this is a great time to be a founder in the B2B space because you can gain an expertise on any field that you find fascinating or interesting without actually, and do it very rapidly because of these AI knowledge systems, right? So, for example, 10 years ago, if I didn't know much about marketing analytics, I have to consult with a lot of marketing professors, read a lot of literature, get up to speed. But if you're somewhat of a polymath and reasonably curious, you can actually become an expert in anything you want to be in a much shorter time because the language model tools help you accelerate your learning significantly. So if you have a great idea for a B2B, don't stay focused in your current field of expertise. I would say broaden your horizons and then try to expand your knowledge base based on what you can read and understand, and apply your same principles. As long as you can build things from first principles, you can actually build a system to solve solutions in any field. So you don't have to be so I think you can be that. I think is the greatest thing that has happened, and then it's going to be the best thing for a lot of the next generation of engineers and solutions providers because you don't have a narrow focus anymore. For example, I'm an electrical engineer. I transitioned to data science, but I believe I could have made the transition a lot faster if I was living today, right? So it's a great time to be an entrepreneur right now.
Yeah, that's right. That's beautiful. And Rajiv, thank you so much. That was sharp, thoughtful, and really useful for anyone building or buying in this space. Thank you so much.
Thank you, Laurent. Thank you for the insightful conversation, great discussion, and appreciate the time.
Yeah, very, very insightful. And I'm very curious to know more. Basically, you opened my desire for more questions, but the time is short. Where can people go and learn more about you or quantum data technologies?
Yeah, they can come to our QDT.ai or connect with me on LinkedIn. I'm happy to interface with them. We have a very strong and our team is we have a strong but very insightful and then very powerful team. I would say we're an agile team and we love doing new things. So happy to connect with anyone of interest who is interested. Please visit us at QDT.ai. Connect with us on LinkedIn or on our social feeds.
Wonderful. Thank you so much. Perfect. That's it for today's episode of AI Interconnect. And if you enjoy it, share it with someone who is building the future, or better yet, someone who should be. And until next time, stay curious, stay creative, and keep building.
Thank you.
Thank you, Rajiv.
Thank you.
Thank you.